Good afternoon, everybody. Hello, I'm Tracey. Today I want to talk to you about ICT solutions for energy positive neighbourhoods. And a little after I've spoken, my colleagues Christian and Pascal in France and Finland are going to talk to you about some of the work we've done at the pilot sites. The work I'm talking to you about today represents the findings of an EU FP7 project called Ideas. The project started in November 2012 and finishes later this month. We had 9 European partners from 9 partners from Europe and from Israel. Teesside University was the project coordinator. The partners included VTT in Finland, CSTB in France, 2 parts of IBM, one from Israel and one from France, Norbitec, Povun Energia, and Povun Kapunki, which is a local authority in Finland, and Pacintra. Okay, so the main objective of our project was to illustrate how communities, public authorities and utility companies can be engaged in the development of energy positive neighbourhoods. At the outset of the project, we didn't have a definition of an energy positive neighbourhood. So what is it? We defined it as an area in which the annual energy demand is lower than the annual energy supply from local renewable energy sources. However, importantly, we also thought that the energy infrastructures should be connected to the wider energy networks and contribute to the optimisation and security of those wider networks. So what does this mean? So in a sense what we mean is, given the right market conditions, that an energy positive neighbourhood will act as a good citizen in that it will store energy to be sold to the national grid when national energy demand is high, and it will also help to resolve the problems associated with integrating distributed renewable energy production into national energy networks. We also, during the project, had to define some way of measuring and promoting energy positivity. So we developed KPIs to measure the energy positivity of an area, and we also developed an energy positivity label to communicate the concept. This label is very similar to those that you will recognise from white goods, and my colleagues Christian and Pascal will talk to you about them in more depth in their presentations. Okay, to realise an EPN, an energy positive neighbourhood, it's necessary to optimise the production, storage and retrieval and selling of renewable energy at the neighbourhood level. In Ideas, the approach we took involved balancing real-time energy supply and demand within a neighbourhood by employing smart distributed renewable energy generation and storage, encouraging the local consumption of distributed renewable energy generation, and supporting energy-efficient urban design. And the main outcomes of our project are a reduction of energy demand and CO2 at the pilot sites, and importantly, validated Ideas business models and tools which optimise energy trading and local energy supply and demand solutions. So the main aim of the business research was to identify how utility companies and local authorities across Europe can be profitably engaged in the development and operation of EPNs. Here it's very important to note that we're looking for the way in which current utility companies and energy service companies can be involved in the development of an EPN as an extension to their current business models, enabling them to integrate distributed renewable energy generation in order to reduce CO2 emissions. So why should the utilities industry be interested? Well, matching local renewable energy supply with local demand mitigates congestion on electricity distribution networks. It enables savings on investments in grid capacity and congestion management. And importantly, excuse me, there appears to be a fire alarm. Hopefully it's just a test. I wasn't warned. I do apologise. Electricity is stored and sold outside of the EPN when national energy demand is high. So, in Ideas, we demonstrated how energy positive neighbourhoods can be implemented by designing and demonstrating a neighbourhood energy management tool to optimise energy production and consumption, user interfaces that engage communities and individuals, a decision support urban planning tool to optimise the planning of energy infrastructures, and business models that support the incremental rollout of the regulatory, economic and social infrastructures required for energy positive neighbourhoods. So the tools and user interfaces and elements of the business models developed were demonstrated at 2 sites, part of a university campus in Bordeaux, France, which houses the University Institute of Technology, and the Omenetaha residential neighbourhood in the Skavtjärvi area of Porvoo, Finland. It's important to note that the ideas business models reflect the current aspirations of stakeholders at the demonstration sites. We wanted to develop things that were of interest to the partners taking part in our project. Okay, so in the project we developed 2 distinct business models. Both are based on the use of biofuel CHP, combined heat and power, combined with forms of renewable energy production. One was for what might be called a district energy supplier, and one for what might be called an integrated energy supplier. Both are integrated business models in which innovating firms bundle innovation and product together and assume responsibility for the entire value chain of supplying affordable, locally produced, renewable energy. So in a sense, they generate, distribute and sell renewable energy. A district energy supplier focuses on customers, predominantly residential customers, whereas an integrated energy supplier installs and maintains renewable energy and e-production for an organisation that owns a group of buildings in the same geographical location, such as a university, as in our pilot site, larger schools, hotel complexes, hospitals, etc. In this case, the integrated energy supplier might also provide consultancy services and renovates buildings. It would help customers select the best renovation solutions and help them implement those solutions in building renovations. Importantly, both business models are based on increased revenue from reduced costs for energy production and increased profits from optimising the production, storage and retrieval and buying and selling of energy. So what was our impact at the pilot sites? Well, with the neighbourhood energy management tool, we managed to illustrate that up to a 30% increase in the effective value of renewable energy. What we mean by that, we ran some simulations and looked at the effective value of the renewable energy to be sold either to an energy supplier or through an energy aggregator on the wholesale markets, and showed that by using our optimisation approach, you could increase the profits from the electricity produced by CHP by up to 30%. And we also illustrated up to a 10% increase in the efficiency of the energy plant. In the user interfaces we demonstrated, we showed that consumers are more aware of their energy use and how to reduce it, and up to a 5% reduction in energy demand and CO2 emissions were achieved using the user interfaces that we developed and implemented. And for the decision support urban planning tool, we showed that it was clearly able to show the assessment of different interventions in energy supply, distribution and urban design, and demonstrate a return on investment of those of between 10 and 29 years. So, the business potential. Optimising the storage and selling of energy can significantly increase the effective value of renewable energy, increase the efficiency of energy plant, reduce congestion on electricity distribution networks, and reduce the need for investment in grid reinforcement. The potential, however, could be improved by more innovative approaches to feed-in tariffs. In many of the countries across Europe, standard feed-in tariffs are used, and you get the same value for your electricity, no matter the time of day which you sell it. However, a more innovative approach is a premium-based fit, in which you pay a premium on top of the market price, which fluctuates according to wholesale prices. It's also important to note that there has to be a strong relationship between local authorities and energy companies if we're going to achieve an energy positive neighbourhood. If we think about it for a moment, we have to include the development of an energy positive neighbourhood in urban planning. If you're going to have energy storage, for example, you have to have somewhere to put that storage, and that has to be included in your urban planning. And also, we've done some work which looked at differential tariffs for electricity distribution that favour the local consumption of distributed renewable energy generation. The problem is that a large percentage of our electricity costs are related to distribution, which is a fixed cost. And this can be somewhere between 20 and 40% of your energy cost. And if this stays static, it's really difficult for us to have a big impact on the cost of energy. So we did some work looking at a differential tariff, some simulated work for inside the energy positive neighbourhood and outside. And if we had a 50% tariff inside the neighbourhood as compared to outside of the neighbourhood, this could increase the effective consumption of locally produced renewable energy by up to 50%. Okay, so achieving energy positivity at the demo sites. Okay, at the Finnish demo site is currently at about level B, and the French demo site is currently at about level C. Level B is quite good, with 98% of the energy demand produced from renewable sources. And Christian will talk to you a little bit more in the next presentation about how we could improve this. At the French demonstration site, Pascal will discuss with you how we could move the French demo site further towards energy positivity. And thank you, and I think we can now move on to questions.